Welcome back. We're on part 5 and the final part of inequalities. I have one last example to show you. Here we have a rational expression on each side of the inequality, and we need to get it with a 0 on the right side. So I'm going to subtract the x minus 1 over x minus 2 from both sides. You could also think of it as moving the rational expression on the right over to the left. Now we have x plus 2 over x plus 3 minus x minus 1 over x minus 2 is less than or equal to 0. At this point, I need to get a common denominator. My least common denominator, or LCD, is going to be x plus 3 from the first denominator times x minus 2 from the second denominator. The way I get a common denominator is by building up the denominator using a funny looking 1. The x plus 3 is missing an x minus 2, so I multiply by x minus 2 over x minus 2, and the second rational expression is missing a x plus 3, so I'm going to multiply by x plus 3 over x plus 3, and now I will have a common denominator. Now I need to expand the numerators via multiplication and then write it all over the common denominator. When I FOIL x minus 2 times x plus 2, I will get an x squared minus 4. When I FOIL x minus 1 times x plus 3, that will give me x squared plus 2x minus 3, all over x plus 3 times x minus 2. And that is less than or equal to 0. Distributing the negative sign and combining like terms will give me x squared minus 4 minus x squared minus 2x plus 3, all over x plus 3 times x minus 2. Notice these are already binomials, and they're already factored in the denominator, so don't FOIL the denominator. That's just one extra step, because then you'll have to factor it again. We know that x squared minus x squared adds to 0. We have a negative 2x and a negative 4 plus 3. That will give me a negative 2x minus 1, all over x plus 3 times x minus 2, less than or equal to 0. The first vertical asymptote will be at x equals negative 3, and the second one will be at x equals 2. Here's my number line. I have a vertical asymptote, or a hole, at negative 3, and also at 2. If I take the numerator and set it equal to 0, so we have x is equal to negative 1/2, and so I'll put one more interval break at negative 1/2. Notice that I've included the endpoint at negative 1/2 because this is less than or equal to, and this is not in the denominator. This is in the numerator. So now I just break my number line up into intervals. My first test value to the far left will be a negative 4. We'll go with negative 1 between negative 3 and negative 1/2. We'll do a 0 for my test value between -1/2 and 2. And we'll do a 3 for my test value between 2 and infinity. Substituting -4 into my inequality, I will get a positive over a negative times a negative. This will give me a positive interval. Substituting -1 into the inequality will give me a negative divided by a positive times a negative. This will give me an overall negative interval. Substituting 0 in will give me a negative divided by a positive times a negative. This will give me an overall positive interval. Substituting +3 in, we will get a negative divided by a positive times a positive. This will give me an overall negative interval. Now remember, my inequality says anything less than or equal to 0. That means I need negative intervals. So highlighting those intervals. Now I write my final answer in interval notation, open parenthesis because I'm not including the -3, comma, -1/2, close bracket because I'm including -1/2 as my endpoint, union because there's a break in my interval, open parenthesis because I do not include the 2 at the vertical asymptote, comma, infinity because it keeps on going, close paren because we never reach infinity.